Loops allow us to repeat a block of code multiple times without rewriting it. It's one of the most powerful tools in a programmer's toolkit for handling repetitive tasks efficiently. Let's break down how this process works using this flowchart. Start. Everything begins here. The program enters the loop and prepares to process a sequence of items. The decision, last item. The orange diamond represents a condition. The program asks, have I reached the end of the list? The no path statement. If the answer is no, the program moves to the blue block to execute the statement. This is where the actual work, like printing a value or performing a calculation, happens. The loop back, try next number. After the statement is executed, the flow follows the path back up to try the next number and checks the condition again. The yes path, and once the program confirms that it has processed the last item, it follows the yes path, exits the loop, and reaches the end. And that is the logic of a for loop: check, execute, and repeat until the job is done. Now, let's see how that flowchart looks in actual code. We'll use a simple Python example to print numbers from 0 to 4. Take a look at this line, 4i in range 5. You might wonder, why does it stop at 4? In programming, we almost always start counting from 0. So when we ask for range 5, we are asking for exactly 5 numbers in total. That sequence is 0, 1, 2, 3, and 4. The number 5 acts as the stop sign. It tells the program where to stop, but it isn't included in the count itself. The variable I acts as our placeholder for each item in that sequence. Inside the loop, we have our statement, print I. First pass, I starts at 0. Is it the last item? No. So it prints 0 and moves to the next number. Repeating, the loop continues through 1, 2, 3, and finally 4. The end. After printing 4, the program checks the sequence again. Since the next number is 5, our stop sign, the answer to last item, becomes yes. The loop terminates. Just like that, we've executed 5 lines of output, 0 through 4, with only 2 lines of code. Efficient and clean. Instead of numbers, loops can also move through a list of items. Let's look at this collection of fruits. We define a list, fruits equals apple, banana, cherry. Then we start the loop, for fruit in fruits. Here, the variable fruit acts as a temporary container that holds one item from the list at a time. The process follows our flowchart perfectly. First step, the program grabs apple, checks if it's the last item, no, and prints it. The cycle, it moves to banana, prints it, then moves to cherry. The exit, after printing cherry, the program asks, are there more items? Since the list is empty, the answer is yes, this was the last item, and the loop ends. Now, let's look at a different type of loop. Use this when you want to loop as long as a condition is true. Unlike the for loop, you might not know exactly how many times it will run. As we saw before, the for loop runs a command first and then checks if there's more to do. It's perfect when you have a fixed list of items. But look at the while loop on the right. Notice the difference in the flow. The guard at the door. In a while loop, we check the condition before doing anything. The true path. If the condition is true, the program moves down to execute the command. The guard at the door. In a while loop, we check the condition before doing anything. The true path. If the condition is true, the program moves down to execute the command. The loop back. After the command, it jumps right back to the top to check the condition again. The exit. The moment the condition becomes false, the program skips the command entirely and goes straight to the end. Think of it like this. A for loop is for a set list, while a while loop is for a set condition. It keeps going until the situation changes. Let's see the while loop in action with this simple counter. We start with count equals 0. Our condition is while count 5. This means the loop will keep running as long as the count is less than 5. Each time the loop runs, first, it prints the current number. The crucial step, we add count equals count plus 1. This updates our condition. The result, the loop prints 0, 1, 2, 3, and 4. Once the count hits 5, the condition becomes false, and the loop stops immediately. The result, the loop prints 0, 1, 2, 3, and 4. Once the count hits 5, the condition becomes false, and the loop stops immediately. Sometimes you need to change how the loop runs while it is happening. Python gives us two powerful commands to do exactly that. First, we have break. Think of it as an emergency exit. In this code, as soon as our number hits 3, the break command stops the loop immediately. It doesn't matter if there were more numbers left, the loop is over. Next is continue. This is more like a skip button. When the number is 3, the continue command skips the rest of that specific turn and jumps straight to the next number. You'll see that 3 is missing from the output, but the loop keeps going until the end. Conclusion: so use break to stop everything, and continue to just skip a step.